not from current slide. Okay, let's see. We already did rates of change, didn't we? Yep. And we did. Ooh. There's example 11. All right. I didn't see example 10. We did example 10 though, didn't we? I have that we did, so say yes. Okay. We'll go from current slide. Okay. Any questions on anything before we finally get started today? All right. I do want to make this announcement again. This coming Friday, normally I have office hours in the Birmingham West Campus from 8 till 12. Not this Friday. Probably not next Friday either. But this Friday, I know I'll be on the road to Opelika by 8 o'clock. Probably most of the way there by 8 o'clock. And I will be in the middle of meetings at noon. So I won't be getting back to Birmingham until probably after 5. So it's the whole day shot. So I will not be on the Birmingham campus or this campus or any campus except Opelika campus on this coming Friday. And since I'm going to be occupied a full day with that, I will not probably not be on campus again next Friday because I will have been so many hours over. All right, any questions? All right, example 11. At time, and by the way, we're doing rates of change, which basically, rate of change is a d by dt, basically. Change of something for change of time. And here we'll be using a derivative to find velocity. At time t equals 0 seconds, a diver jumps, now doesn't fall, but jumps from a platform diving board 32 feet above the water. So the board, 32 feet above the water. Because, looks like a heap, okay, because he is jumping, there is an initial velocity, and that's upward, 16 feet per second. That's his initial speed. Off the board, going up, and slightly out, so he doesn't catch the board on the way down. So, not very much out, but slightly out. The question, when does a diver hit the water? Okay? And then the second question will be, what is the diver's velocity at impact? Okay. So, what do we know here based on what we've done before? And just as a quick refresher, because I know it was a long weekend, here is the formula we use. S of t, now S stands for displacement, okay, as a function of time, is minus 1/2 g, acceleration due to gravity, and that's 32 feet per second, 32 feet per second squared, or 9.8 meters per second squared, or meters per second, plus v0t plus s0. That's the position function, okay? So, let's write that down here once I get my pen set up, okay? S as a function of time is minus, why minus? Acceleration due to gravity is always toward the center of the earth, down, so that's negative. Negative 1/2 gt squared, and there's the acceleration due to gravity, so that's why it's always down, plus v0t plus s0. That it? Now, let's identify from what we're given here. At time t equals 0 seconds, the diver jumps from a platform diving board that is 32 feet above the water. So at time t equals 0, he's 32 feet above the water. Well, that's the initial displacement, 32 feet, okay? The initial velocity of the diver, and why they capitalize velocity, I don't know, is 16 feet per second. So that's your V0t, 16 feet per second, okay? Now, because we're using feet and feet per second, what G do we use? One of these two here. Which one? 32 feet per second squared, okay? So the G that we use is 32 feet per second squared, all right? So the question is, when does the diver hit the water? Well, let's plug in what we know. Okay, fill me in on something. Where is the water? It's down here at S equals 0. Because that's plus 32 up there. So S equals 0, here's where the water is. So that's our S of t. We just don't know what time it is. So our equation is at 0 is equal to negative 1/2 gt squared. Well, let's go on and plug in. G is 32 feet per second squared. I'll leave off the units now just because they take up so much room. But you see, feet per second squared multiplied by second squared, that will give us feet. That's good for here. Plus 16 feet per second times t, which will be in seconds. That will give us feet, plus 32, our initial height. Okay? Notice everything here is a multiple of 16, isn't it? And half of 32 will be 16. So here basically we have 0 is equal to minus 16 t squared plus 16t plus 32. Have we used any calculus yet? No, except to derive the formula. That was what we did before. So what would you do to that? What would be your first step? Sort of back in college algebra or somewhere. Absolutely. And what I'm going to do is move things to the other side. Is that okay? So that will be factoring out a 16, in other words, dividing everything by 16. That'll be 0, and this will be, I'm moving to the other side, so it'll be t squared plus t, minus t, because I'm moving to the other side. Minus t minus 2 is equal to 0. So I did two things. Actually, the other way you can look at it, factor out a negative 16. Divide everything by negative 16. That becomes 0. This becomes t squared. If you divide by negative 16, that becomes negative t. That becomes negative 2. Now, what can we do with this? You used the right word before when you said factor out the 16. Can we factor any further? Anybody?
Yes.
How? T minus 2 times t plus 1. Is that what I heard you say? Say yes? Oh, yeah, okay. Now, what does this give you? T equal 2 seconds, or T equal -1 second. Okay? Yeah, I think he hits the water after he jumps off the board, not before he jumps off the board, okay? So we'll say 2 seconds later, he hits the board, he hits the water. Now, you don't need to know this, this is important. What in the world would that represent anyway? That would represent if he was on the springboard down here and went up that high and came down. It would have been 1 second earlier. But that is a pretty powerful springboard. I wouldn't want to be on it. Okay. So anyway, that's the first. When does the diver hit the water? 2 seconds after he jumps. Okay. Now, what is the diver's velocity at impact? Okay. How are we going to get that? Plug in what? Where? Where? Up there? I guarantee I'll tell you what you get. You get S equals 0. Because that's, you plug in a T here or a 2 here, you get equals 0. Ha! We need to know what the velocity function is. And how is it? If we know the displacement function, what is the velocity function? Did you have a hint that, okay, I think we ran across this last time. A couple of you weren't here. At least a couple weren't here. What's the Jesus answer? Say again? Oh, yeah, yeah, y'all remember so well. Okay, let's see if going back in time will remind you. Oh, here we go. V of t is equal to S prime of t. So now what's the Jesus answer? What's the derivative mean? I mean, what's the prime mean? Take a derivative. Y'all forgot, didn't you? Okay. All right. Y'all are going to flunk Sunday school. Okay, never mind. Okay. So what do we do? Here's the velocity function. Second, V of t is equal to, what did we just say? S prime of t, and what would that be? And we can go on and put the 32. In other words, we can -1/2 of 32 would be minus 16 t squared plus 16t plus 32. Okay, we can write it that way. Oh, wait. Sorry. This is S of t. Minus 16t squared plus 16t plus 32. Now, take a derivative of that. And what does that give you? If you can read my writing. Yeah, S prime of t. This is S of t up here. We want S prime of t. And that's a minus 16. This is getting worse and worse. Okay? I'm trying to make it look neater, and it just looks worse. Okay? So S of t, S prime of t would be what? Minus 16 t squared plus 16t plus 32. You have to go back and get how you take a derivative. Please say we don't. It was a long weekend, wasn't it? Oh my goodness. Working all those homework exercises just made you forget it all, didn't it? Oh, no, they would help you remember, wouldn't they? How do you take a derivative of that? Exponent times coefficient, does that ring a bell? Oh, yeah. What would that be? 2 times negative 16. Negative 32 what? My pen's not writing. Now it's gone off. Okay. Now it's 32 t, excellent. Next, plus 16. Got it. Now this is what we plugged the 2 into. The v of 2 would then be what? Negative 32 times maybe go back to math 120, huh? Say again? Times, yeah, 2. T is 2. Plus 16. That would be negative, say again? Oh, you mean total? Yeah. 64 plus 16 is equal to negative 48. And that would be feet per second. I didn't keep up with the units, but that's what it would be. Feet per second. Okay? That's because the first term there was that 16 was feet per second squared. When I took the derivative, that made it 32 feet per second squared, and 16 was feet per second. So this comes out feet per second. So it's multiplied by t, 2 seconds, and that wiped out one of the seconds. So that means it's going negative 48 feet per second toward the water. Now, just as a hint, I don't do platform diving, okay? But if you ever were doing platform diving, that's approximately a 10-meter board, if I'm not mistaken. That's pretty far up there, 32 feet. You're at a speed of 48 feet per second hitting the water. Notice how his hands are like this. That's how you want them to be. If you do like this, you're probably going to sprain a wrist, maybe even break it. If you don't have your hand there, then your head is breaking the surface tension of the water. And if that has not been disturbed, you're going to have a headache or a concussion or a broken neck or something. I mean, it's no trivial matter. That's going pretty fast to hit a plain sheet of water. And I bet you some of you in your lifetime have jumped off the side of a pool and done a belly flop. And that hurts there. Just think what it would be at this speed. Okay. You don't want to do it. A lot of divers come away with jammed fingers even when they're doing it properly. Okay. You don't want to do it. All right, let's see how they did it. Begin by writing an equation to represent the position of the diver using the position function given way back with g is equal to 32 feet per second, or feet per second squared, I like to say. V0 is 16 feet per second, S0 is 32 feet. You can write S of t is equal to minus 1/2 times 32, that's the g here, t squared plus 16t, there's that 16t, plus 32. The minus is here because the acceleration is always negative, going downward. And then when you plug that in, you get that. There's your position function as a function of time. S position as a function of time. Okay? To find the time when he hits the water, let S equals 0. That's going to be his position when he hits the water at the bottom. S equals 0. Okay? Solve for t, which we did. Factor out the minus 16, and that gives us either t is equal to 1 second, or negative 1 second, or 2 seconds. Negative 1 second doesn't make any sense because he has to hit the water after he jumps off the board rather than before he jumps off the board. So choose the positive value to conclude he hits the water at t equal 2 seconds. Now the velocity, then, you take the derivative of that displacement function there, s of t. Take the derivative of this to give you s prime of t, which is, do it again, Sam. Negative 32 t plus 16. That's how they got that, okay? S of t is equal to negative 32t plus 16. To find it 2 seconds after he jumped, plug in the 2. And that would be s prime of 2 would be negative 32 times 2 plus 16, which is minus 48 feet per second velocity. Any questions on that? Notice that the unit for s prime of t is the unit for s of t feet divided by the unit for t seconds, okay? In general, the unit for f prime of t is the unit f divided by the unit for x, f prime of x. Because think what the f prime or the s prime stands for. S prime in this case is ds dt, okay? That would be the units for s, feet, divided by the units for t, time, second, feet per second. So, same thing here. F prime of x, that stands for df dx, right? That's the independent variable. Whatever the units for f was, divide by the unit for x. That's a good rule of thumb to follow because that's what you're doing. Change of s for change of t. Change of f for change of s. That's what a derivative is telling you. All right, any questions? That ends 3.2, finally. Okay. By the way, I haven't been saying this every time. At the beginning of each homework exercise, there is what they call a concept check. And I don't know if these are also, the odds here are also at calcchat.com. I'm guessing they are. They should be. But these should be things you think through and make sure you understand those concepts before you proceed. So the homework exercises would be 5. That's at CalcChat and CalcView. Any of the odds 7 through 25, they're all at CalcChat. 17's at CalcView. 27 or 29, both at CalcChat. 27's at CalcView. Any of the odds 31 through 39, they're all at CalcChat. 37's at CalcView. Any of the odds 41 to 57, they're all at CalcChat. 45's at CalcView. Either 59 or 61, both at CalcChat. 59's at CalcView. Any of the odds 63 to 69, they're all at CalcChat. 63's at CalcView. Either 71 or 73, they're both at CalcChat. 71's at CalcView. You can explore doing either 75 or 77. They should both be at CalcChat, as should 79, or 81, or 83. So do any of those you choose. They should all be at CalcChat. 85 should be at CalcChat. 87 should be at CalcChat. Then you have some true-false, 89 through 93. They should all be at CalcChat. Then finding rates of change, 95 through 99, they're all at CalcChat. 95's at CalcView. 101 should be at CalcChat. That's one similar to what we just did, only a few more questions involved. Then again, another vertical motion, 103, using, now the difference in 101 and 103, anyone notice what the difference in 101 and 103 is? Say again? What?
Multiple choice. 101.
Oh, it's not multiple choice. It's
Oh, it's multiple. Okay.
you got several things to answer there, but 103 only is a couple of questions. But of the functions, look at the S of T's for those. What's the difference there? See your S of T? For 101, vertical motion, and then the S of T for 103. Say again? Okay. I think you're meaning, okay. Did you say volume or velocity? Oh, I see. Okay. Okay. No, okay. If you got this book, the S of T for 101 is minus 16 T squared. Do you see that? And what is it for 103? Oh, how can you have two different position functions? One's in feet per second squared, and the other is in meters per second squared. The two different G's, remember? One is metric, the top one is US customary, the second one is metric, or SI units. Then proceed to, you can think about doing 105, and then 107 is a volume problem. Is that the one that you had? Volume of a cube of length side? Okay, that may be where the difference is coming in. Okay, sorry about that. I didn't realize the books had different things. 109 is a modeling data. All these should be at Calc Chat. Then you can do 111 is a velocity problem like we were just doing. That should be at Calc Chat. 113, 115, do any of those odds that you want to do. They should all be at Calc Chat. 117 should be at Calc Chat. 119 should be at Calc Chat. Wow. They put a lot of exercises out there, don't they? Or they call them, exercises. So let's move on to 3.3, if I can get the computer to do something. Okay. So let's can that one and go on to 3.3. Big long chapter here, folks. We're probably not going to do it all, but let's keep moving on it. So far, we've done constant multiple rule, power rule, addition subtraction rule. What are we missing here? Let's get the slideshow set up from the current slide. So chapter 3 is differentiation. In other words, taking derivatives. Hint, hint. Okay. 3.3 is product and quotient rules, and then higher order derivatives. Okay? Our objectives here then will be find the derivative of a function using the product rule, find the derivative of a function using the quotient rule, find the derivative of a trigonometric function. That's probably not in your section. That will be in 5 somewhere. And find higher order derivatives of the function. That probably should be in this corresponding section that you have. Okay. So let's start with the product rule. For addition and subtraction, if you take the derivative of a sum of two differentiable functions, it's f prime plus g prime. So for a product rule, should that be f prime times g prime? No. Okay. In fact, I think Leibniz, one of the creators of calculus, was in such a rush to publish and beat Newton that he published that, and then people did it and said, hey, this doesn't work. And he had to go back to the drawing board and find out, nope, he got the product rule wrong. Now that's my memory. I hope that's right. It says here, you learn that the derivative of a sum of two functions is simply the sum of their derivatives. Same thing for difference of two functions. It's the difference of their derivatives. The rules for derivatives of product and quotient for two functions, not as simple. Okay? Like what Leibniz was wishing for. You probably were too. The product of two differentiable functions, f and g, is itself differentiable. Moreover, the derivative of the product, f times g, is the first function, and it doesn't really matter on this, one function times the derivative of the other, plus the other times the derivative of the first, the one, okay? So here's the product rule. D by dx, don't you like saying that, of f of x, g of x, is f times g prime plus g times f prime. And guess what? It works just as well to say g times f prime plus f times g prime. Because it's the same thing, and multiplication is commutative and addition is commutative. So it doesn't matter which order you do them. When we get to the quotient rule, it matters, okay? But for the product, it doesn't. But it is the product of one function times the derivative of the other, plus the sum of that, plus the second function times the derivative of the first, or whichever the other was times the derivative of the one. Okay. The product rule can be extended to cover products involving more than two functions, more than two factors. For instance, f, g, and h are all differentiable. They've got to be differentiable functions of g. Then, d by dx of f, g, h would be f prime times the product of g and h, plus f times the product, f times h times the product derivative of g, plus f times g times the derivative of h. Okay? And you can keep on as long as you want to. You probably don't want to do that many products, but you could. So the derivative of this one, whoa, they jumped right into it. What would that be? Derivative of this y. One? Is that what you said? Wow. Okay, no. How would you do it? The way they did?
It gotta be, there is no,
Okay.
derivative.
Huh?
There is no derivative.
Oh, really? Oh, new rule here. Okay, why not? Is x squared not differentiable? Yeah, it is. Sine differentiable? Yeah. Cosine differentiable? Yeah. Everywhere they're differentiable. So yeah, you can take the derivative. What would it be? Any guesses? Derivative of the first, which would be 2x times sine x cosine x. What's next? Plus x squared, there's your f of x. What's the derivative of sine x? Cosine x times cosine x. So that's cosine squared x, right? All right. Plus x squared sine x times derivative of cosine, which is negative sine. So that would have been a minus x squared cos sine x, or sine squared x. So if we write that down, 2x times sine x cosine x plus x squared times cosine squared x minus sine squared x. Put that together. Now, does anyone remember what this is? Cosine squared x minus sine squared x? Actually, one of those sum difference identities. Which one? Anyone remember? Got to talk with some trick teachers here. Okay. This is cosine 2x. This is 2 times sine x cosine x. Anyone remember that one? Sine 2x. Okay? You need a little refresher in through? Okay, let's do it quickly. Hopefully this will ring a bell somewhere back there. Let me get my pen set up. Okay, sine of, let's say, alpha plus beta. That's sine alpha cosine beta plus sine beta cosine alpha. Okay? Does that ring a bell? Okay. What if alpha is equal to beta then? So this is sine of 2 alpha. That would be sine alpha cosine alpha, which would be sine alpha cosine alpha plus sine alpha cosine alpha, which is 2 times sine alpha cosine alpha. And if alpha was x, then these right here would be x times sine of 2x plus x squared. Okay, we need to do the same thing for cosine. Let's do it. Cosine of alpha plus beta is, anyone remember that one? Cosine alpha cosine beta minus sine alpha sine beta. And by the way, just for your cultural enlightenment, inside front cover, there's a page that looks like it's perforated, sort of a cardstock page, okay? And these are called the double angle formulas. The sine of 2u, or 2 alpha, or whatever, is 2 times the sine alpha, that's sine u cosine u. And then cosine 2u has 3 different forms, but the first of those is cosine squared alpha. So if alpha is equal to beta, then cosine 2 alpha is equal to cosine squared alpha minus sine squared alpha. So that's where you get cosine 2x. You didn't have to go there. This is a perfectly good answer, but this takes less than work. Right. So let's see if they go that extra mile too. No, they don't. Shame on them. Okay? But you could have taken that one more step. Okay? It's okay if you don't. They didn't. So you didn't have to, but it does go one more step. Okay. Derivative of a product of 2 functions is not in general given by the product of the derivatives of the 2 functions. Okay? Let's see if they're going to do another example. Yes, they do, but they do it separately. Find the derivative of h of x if h of x is the product of 3x minus 2x squared times 5 plus 4x. Okay? That's the example they give at the top. But let's see what we get. What would be h prime of x? Remember how we do it? Anybody? What the rule is? If this is your alpha of x, and this is g of x, what would be your h prime? Anybody? Did I hear? Alpha of x times g prime of x plus g of x times f prime of x. Okay? What's your alpha of x? 3x minus 2x squared. What's your g prime of x? No, that's g. What is g prime? Take a derivative of that. Anybody? Not that hard. Derivative of this thing right here. G prime. Say again? Okay, wait. What's the derivative of a constant? What's the derivative of a constant? Anybody? Huh? What's the slope of a constant function? 0. Derivative of a constant is 0. Remember? The constant rule. Ooh, longer. 4. That would be it. Okay? Plus, what's your g of x? 5 plus 4x. That's a 4x. It's ugly. Times 3 minus 4x. Excellent. Okay? That's the derivative of f prime. Right? So, let's multiply through, and what do we get? Distribute the 4, and what do you get? A little louder. 12x minus 8x squared plus, now we got some foiling to do. 15 minus 20x plus 4x. Yeah, you're making fun of my writing. Okay. What does that give you? Plus 12x. Okay. And then last, minus 16x squared. Combine like terms, and what do you get? I kind of like starting with the 15. So let's start with the 15 and write them in opposite order. Okay. And then I think we're going to have a plus here because you got 12x plus 12x is 24x. Minus 20x would be 4x, right? And then you got a minus 24x squared. Make sense? Do you believe it? With all your heart. Here's one way to check. And you might find it almost easier than what we just did. Okay? And that's because these are two binomial functions. What if we took that h of x and just multiplied it? H of x is equal to, I think I'll wipe out the f and g now because we've already done the product rule. But this says, so let's do that. What do we get? It's multiplying two binomials together. What does that give you? 15x. Then the outer is plus 12x squared. Then the innards are negative 10x squared. And then the last is negative 8x what? To the third. Good. Now do h prime of x, which is what we were doing before, right? Oh, before we do that, let's combine like terms. So this gives us 15x, right? When you combine those two like terms, what do you get? I'm sorry? Plus 2x minus 8x cubed, right? So let's take the derivative of that. What does that give us? 2x squared, you're right. Okay, thank you. Take the derivative of that. What do you get? 15 4x minus 24 x squared. Hey! Looky there. H prime is the same either way. You could either multiply first and then take a derivative like we did here, or use the product rule there. Y'all chose to do the product rule because it was a little harder and you wanted to practice it, remember? Yes, good choice, okay. All right. Most of the time you won't be able to make it easier that way. But there's your answer. And they wrote the minus 24x squared in front. That's fine too, okay? Now, let's see how they did it. I bet you they did it somewhat similarly to what we did the first time. Can I erase? All right. Okay. The solution is designate this the first times derivative of the second plus the second times derivative of the first. That's the product rule. Though you can do it mix and match as long as you keep everything together. Okay. And that would be 3x minus 2x squared times 4, exactly like you did, plus 5 plus 4x times the derivative of that would be 3 plus 4x. Perfect. Then you multiply those two together and you get those terms. Combine like terms, you get minus 24x squared plus 4x plus 15. Exactly what y'all got, we got, except I put the 15 in front. Minus 24x squared at the end, because I don't like leading off with a minus sign, though there's nothing wrong with it. Okay. Now, they're skipping. Do I need that up there a little longer? Anybody? Got it? Got it? Okay. So let's do example 2. Now, someone help me keep up with time. I don't have a clock up here. Example 2, find the derivative of y is equal to, now, I know you guys with the other addition won't have this one. Y is equal to x e to the x. You'll find this in chapter 5. When you do the product rule there. Okay? So what we want to find is y prime. Now what will it be? X? So, was there a squared in there? Where'd you get the 2? No, this is x times e to the x. Those are two different functions. Okay? So it's a product. Here's the first function, there's the second function. Okay? So the rule is what? X e to the x. Oh, that's the same thing we had, isn't it? Well, that's because the derivative of e to the x is e to the x. That's that beauty of exponentials. So there's the first times derivative of the second, plus what? Did I hear someone say? I thought I heard someone sort of whisper. The second, which is e to the x. Goodness, my pen's not writing. Drives me nuts. I don't know what's. Okay. Still not writing. Yeah. I don't know. Let me see if pushing this will do anything. All right, let me try this. Sort of like my pen has just suddenly decided it's dead. Ah. I don't know what's going on here. Maybe I don't know if there's a battery in this thing or not. What's that? That's okay. Yeah, trying to tap that. That's my pen. What's that? What's popping up on the screen? What is that? It's just a little, yeah. Well, now it's not even going away. There it went away. What's that? Well, who put the hex on it? One of you did, I know it. Okay. I don't. Okay, we'll just finish this. I have to go steal a marker from another room because I don't usually use markers. We'll finish this with that. See if this marker will work. Okay. Yeah. Okay. So we did the first times derivative of the second plus the second, which is e to the x times derivative of the first. What's the derivative of x? 1. So there it is. Now you can leave it like that. That's perfectly good. Or you can factor out an e to the x, and that gives you x plus 1. Either way is fine. Okay? Nothing special about one over the other. In the book, they did x, e to the x times x plus 1. That's how they left it. So that was example 2. I didn't think about this. Hey, I almost had it back. Let's try this and see what happens. End the show. That's not what I want it to do. Discard that and then come back to current slide. Okay. There it is back again. Why didn't you tell me to do that before, huh? Okay. All right, let's do example 3. Let me erase this. This eraser is not too dirty. Okay. Oh, remind me to take this back to his office. Okay. Find the derivative of this, and this also won't be in, it'll be in your chapter 5 probably somewhere. What if you had y is equal to 2x cosine x minus 2 sine x? Okay? How do we take the derivative of that? Y prime. Somebody help me. Okay, I heard a 2x. Times what? Derivative of cosine, which is negative sine x. That's the first part. Second part, plus cosine x that's just 2. Okay? Now do the derivative of the second term. And by the way, it sort of looks like a quotient rule, but it really isn't. I mean, a product rule really isn't. That's just a constant. Those aren't, you can say it's a constant function, but that derivative, just take the derivative of that. And what do we get? Negative 2 sine, not sine x, cosine x. Okay? Because 2 is just a constant. Okay? If you're taking derivatives of a constant times a function, it's just a constant, negative 2, times the derivative of the function. Derivative of sine is cosine. Right? Okay. Now, again, we can simplify a little bit. Oh, quite a bit. What do you notice here? Yeah, these two add to 0. So that just gives us negative 2x sine x. I didn't see that one coming, but that's indeed what you got. Minus 2x sine x. All right, good deal. All right, continue. Anyone need a little more time with this one? Any questions? You see how we got it? Okay. So let's go on to the quotient rule. If you thought the product rule was a little complicated, it's a little more, but it's not bad. First times derivative of the second plus the second times derivative of the first, okay? But the quotient rule, find the quotient f divided by g of two differentiable functions f and g. They both have to be differentiable, otherwise you can't do this. Is it self-differentiable? If both of those are differentiable, the quotient is at all values of x for which g is not equal to 0. Okay? Because you can't divide by 0. Moreover, the derivative f divided by g, the derivative of that, is given by, get this one, the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the square of the denominator. Oh yeah, that's easy to remember, isn't it? Okay. Let me give you, and basically that's about it. D by dx of f of x, g of x is g times the derivative of f minus f times the derivative of g divided by g squared. Okay? That's it. Okay? And that's how I learned it. Just about everybody else I know who did. But I tutored, I think I may have told you this before, Indian friends of ours, their sons, when they were in high school, and after they got to college, some too. And this one, when he came back from India, where he was doing his undergraduate degree, there you study all term long, and you have one test at the end. That's it. You pass or you fail. Okay? They don't have tests in between. They don't have finals. That's pretty much the European way of doing things too. Well, they did it in India. So he came home and was trying to study for his comprehensive exam. And he knew how to do some of this. And here is how he said, okay? Low d high minus high d low over low low, which is low squared. Okay? And what he means by that, the denominator, the low one, times the derivative of the high one, the numerator, minus the high, derivative of the low, over low low. And it's so much easier to remember than the other, it seems like. You just have to remember you start low. Low d high minus high d low over low low. Okay? Or remember that. Okay? The words up here or this here, however you want to remember it, That's the quotient rule. Low D high works pretty well for me. Okay. I never would have known. The first time he said it, of course, he was the one who, derivative of y with respect to x, he called it d by dx. Oh, what? It was d by dx of f of x or whatever. Okay. So, they do have a proof here, and it is a fairly interesting little proof. And if you want to follow through on it, are any of you math majors? If you are, you might want to pay attention to the proof. Basically, engineers just want to do it. Okay, give me the rule, we'll do it. So here's example 4, bottom of the page. Here's your y is 5x minus 2 over x squared plus 1. So what's the rule? Y prime would be, what's the rule? Low, which is x squared plus 1. D high, which is of, that would just be 5. Perfect. Minus, remember, product rule is a plus. Quotient rule is a minus. That's why it's important you start with low. If you start with high, you're going to get it wrong. Okay? So, in the product rule, it doesn't matter which way you start. Quotient rule, it does. Okay? Minus what?
5x minus 2.
High is 5x minus 2 times d low, which is 2x. Perfect. Okay? All over x squared plus 1 squared. Got it. That's the easy way to write it. And unless there's some reason to do otherwise, leave it just like that. Okay? So let's see what we got. Simplify that numerator some. Distribute first. 5x squared plus 5 minus 10x squared. Say again.
Minus 10x. Negative 2. Oh, negative 2 times 2 is negative 4x.
Okay, but you got a minus here and a minus there. That's plus 4x. You see that? Okay. Watch those minus signs. The only reason they ever develop minus signs was to trip you up. Okay? It's the only function in life is to trip people up. Okay, it's first, let's just pretend the 2x is here. Minus 2x times 5x would be minus 10x squared, and minus 2x times minus 2 would be plus 4x, right? If it helps you rewrite it, okay? Now, what do we do? Oh, and this is all over x squared plus 1 squared, okay? Now what can you do to the numerator? Okay, and what do you get? All over x squared plus 1 squared. Now, if there was any reason in the world that you might expect this to factor some way that you could get a factor of x squared plus 1 out of it, you might want to try to do that. Okay? And it's sure enough, nope. I don't think there's any way that's going to factor, period. Okay? Don't believe there's any possibility there. So I think that's how we'll leave the answer. Let me see. Yeah, that's how they left it. Okay. Always check, just to make sure. Okay. Now, Remember, the only thing we had to be careful for is that your denominator was never equal to 0. Will that denominator ever be 0? Either this one or this one. Neither one will ever be 0 for all real numbers. Okay? So, all right, to erase. Let's see what they did. d by dx of 5x minus 2 over x squared plus 1 is low x squared plus 1, d high, which is derivative of 5x minus 2, minus high 5x minus 2, d low, which is derivative of x squared plus 1, over low, which is derivative of is x squared plus 1 squared. And just like we did, that gave you x squared plus 1 times 5 minus 5x minus 2 times 2x over x squared plus 1 squared. And that's 5x plus 5 minus, and what they did, which is an okay thing to do, multiply those first, and that gave it, with a minus here, that gave you 10x squared minus 4x. And then introduce the minus sign, which is going to negate the second part, and that gives you, why wouldn't they write out one more term if they're going to do it this way, one more line, and that's minus 5x squared plus 4x plus 5 over x squared plus 1 squared. All right, that was the quotient rule. Before we get to trigonometric functions, which we have already been doing, let's go back and do example 5. How are we doing on time? Second? 4 minutes. Let's see. Don't believe we're going to have time to do example 5 in 4 minutes. Want to at least get it started, though. Let's see how many homework exercises you got here. All right. Let's just stop it there. I'm sorry we had so many difficulties today. Got a late start. Computer wouldn't boot off, and then system wouldn't print. Okay? We'll pick up with example 5 next time. Not on the slide set, but we'll pick it up. Homework exercises here would include any of the odds 5 through 9. They're all at Calc Chat, 5's at Calc View. That's using the product rule. Any of the odds 11 through 15, they're all at Calc Chat. 11's at Calc View. That's using the quotient rule. Okay? And then they have finding the derivative at a specific point. Okay? And let me just give you the hint here. Always take the derivative first, then plug in the value. Because if you plug in the value first, you're going to have your f of c is equal to a constant. The derivative of that's always going to be 0. You know that's not going to be true. So always take the derivative of the function first with the variable in there, then plug in at the end. So that's any of the odds 17 through 23. They're all at Calc. Well, let's see. I would say 17 through 19, because 21 and 23 are then going to be using, I don't know, we did that with signs, didn't we? We did, product rule was trig functions. We didn't do the quotient rule. So I'll let you decide there, okay? And we'll pick up and go from there next time. Try to make more progress next time, but made decent progress today. Any questions? I do have a question for you. they're talking about monkeying with the summer schedule. Okay? Normally it's a 10-week summer term. That means this class, in the old days, that meant this class would go from an hour and 40 minutes to something like 2 hours and 10 minutes each. But last summer, they decided to make it 2 hours and 25 minutes each. Now they're talking about going to an 8-week term in the summer, and that would make it either, right now it's an hour and 40 minutes, that would make it, if we did it 2 days a week, that would be 3 hours and 20 minutes each. Oh, longer than that. 3 hours and 40 minutes or something like that. Or 4 days a week at an hour and 40 minutes like we're doing now. Which would you rather do? 2 day a week or 4 day a week? 2 day a week at, 2 day a week at an hour and 40 minutes each, or double that for 2 days a week. 4 day a week at hour 40 minutes each, or double the time for only 2 days a week. That's what I thought.
That 2 day, 2 hour thing?
Yeah.
Never, I'm not gonna do that.
Say again?
I took that 2 hour summer classes, and I'm not doing anything.
Yeah. So now I know some of you have internships or other things. Would you be able to swing it? Don't know. Have to check with them and see. But I just think pretty much by the end of an hour or 40 minutes, it's getting a little old, okay? But last summer, 3 hours and 25 minutes, people were glazing over before we ever reached that. And now they're talking about doing even longer. So my suggestion when they mentioned this, I said, calculus is, I think, got to go to 4 days a week. Do y'all agree? Okay. I'm going to propose that, and well, here's what they said. We haven't decided yet, but the schedules are due on the 1st of March. I said, wait a minute, how can we do the schedule if you haven't decided how long classes are going to be? Well, here was their proposal. We'll keep them the same as last summer, but just make them 8-week thing. I said, you don't get as much as, just make extra assignments. I said, wait a minute. Students are paying for instruction, not extra assignments. So I'm arguing against that. They may go to that. They don't pay attention to faculty arguments most of the time. But, so.
For some people, it's okay to have extra assignments, but some people, they have work to do and stuff to do, not just, school all the time.
Right.
So I think what you're fighting over, I think that's a good thing.
Is what?
So, like you were saying, you're fighting for it. I
Yeah.
think that's a good thing because people got to do. I mean, it's not always school.
Yeah. And so I don't know. And they say, well, still due. Summer schedules are still due on the 1st. I said, well, wait a minute. You've got to tell us what to schedule for. Oh. So, I don't know. I'll try to find out before the 1st, because I've got to have it done then. So you heard my sad song, okay? Wasn't that dreadful? That probably used up more than the rest of the time, didn't it? Yeah, okay. I knew I'd get it out of you somehow. No. Good deal. We'll see you on Wednesday.